Good afternoon, everybody, and a very warm welcome to the inaugural AXA SDA webinar. This particular iteration of which is based around modern methods of construction, or MMC, as they're sometimes referred to, and composite panels. Firstly, I need to let you all know that the session is being recorded and we will be able to share a copy or a link to it in a post-event comm, so you will then be able to share it with your colleagues and direct reports if you feel that appropriate as well. Over the next hour, we're going to navigate our way through the landscape of modern methods of construction and composite panels, hopefully shedding a bit of light on both their benefits and potential risks. As underwriters, it's essential for us to understand the complexity of these modern technologies so that we can effectively evaluate and manage the risks that they present. While these cutting-edge methods and materials do offer plenty of advantages, including lightweight construction, energy efficiency, and all besides, they also pose some quite unique risks, particularly concerning fire spread, and obviously we've all seen the devastating impacts that can have, but also structural integrity and other elements as well. So understanding and effectively mitigating these risks where possible is pretty pivotal to our industry being able to continue to actually provide cover for buildings which incorporate these methods of construction. So it's incredibly important. Throughout this session, we're going to examine some case studies and examples that demonstrate both those benefits and the challenges associated with the construction methods. We're hoping that by delving into these real world scenarios, we aim to provide you with a bit of practical insight that will hopefully enhance your underwriting knowledge and by extension, decision making processes when dealing with these sorts of risks. We strongly encourage you to engage with the content. Ask questions wherever you want. I did mention a couple of minutes ago that we have got a Slido set up, the details of which are on screen now. The good news is it's very, very easy to interact with. You literally just scan the QR code, put in the password, which is also on your screen there, and you're in. You don't need to set up an account or anything, and that will allow you then to answer a poll that we put up and raise any questions that you want, which we will hopefully have a little bit of time for at the end to do a bit of Q&A with our experts. So, I mean, ultimately, what we're looking for here, our collective goal is to equip you and ourselves with a comprehensive understanding of the risks associated with these technologies, so we can mutually make more informed underwriting decisions and effectively manage the risks within the commercial insurance context. So once again, thank you very much for taking the time out of your undoubtedly extremely busy days to spend an hour with us on this particular subject. So let's embark on a hopefully very enlightening journey into the world of MMC and composite panels. So without further ado, I'm going to hand over to Rob Dakin. He is our head of business resilience management and is a man who knows probably more on this subject than most to run through. You've been very modest there, Rob. To run through the agenda and the body of today's content. Over to you, Rob.
Thank you, Sam. Promises, you've built it up there, so let's see what we can do with that. As Sam has said, thank you ever so much for taking some time out. Obviously, we hope we can get plenty out of this session, and if you go back to the original invite, the first line I think read something along the lines of do you know by looking at a building how it's constructed? And that has become increasingly difficult, and for my team, Business Resilience, which is our risk surveying team across the UK, we need to probe, not physically, we're not going to start drilling holes in the building, or not very often, but to understand what's behind that external facade. So there's a packed agenda within this session, and I think just to collectively talk that through, it's the why. Why are we building this way? And then just to delve into the details and give you lots of examples. I'm going to kick off with a quick example, actually. So it's a bit of a did you know, but if you were to visit or pass by a generic drive-through restaurant or coffee house, shall we say, the chances are that building is of modular construction. From the outside, it looks like a nice brick tile building, but they're actually brick slips in 2 or 3 modules internally with a roof cassette, all built in a factory. can be built and erected incredibly quickly from that point of view, but you might not have known that as you went through, and they are designed often to look like your traditional builds, which is where some of the challenges may become. So if we can go on to the next slide, if that's okay, please. An example here, I've just mentioned the modular structure, and this is another example on the image here. And even during construction stage, you look at that and think they kind of look sort of concrete modules, but we've talked about these things before where you would consider them to be similar to a porter cabin, and it's not a porter cabin, it's not a temporary building, it will be permanent. You've got permanent fixings to the ground with foundations built, but the methods are very different, and they can be built and connected together at quite a height these days. But just for the next slide, please, Dee, is what the changes for that. And there's plenty more than this, but just to cover them off effectively, that we live in times where there's been rapid change, global events, etc. All those things have played havoc with contract costs, and of course, with a growing population in the UK, we have to look at how many properties are being built, certainly on the residential side, and supply is outstripping demand right now. So how do we build cheaper and quicker effectively? So one of the things we look at, and again, this list of things here is both positive actually in many respects with other considerations, but you'll know, I'm sure, from data, and when you're looking for on the liability and the casualty side, that construction, the industry is truly incredibly hazardous. It usually sits in the top 1 and 2 at any given time for the most hazardous trades in the UK. We need to do something about that. But building this way, where it's been mainly built in more factory type environments and assembled on site, has to have an impact eventually, and it takes some years for the data to come through, but have a benefit on construction safety. You're using cranes as the kind of banner image at the top shows you. Cranes are moving things into position, and that connection of people, heavy transport and machinery and materials all in the same relatively tight space, often in urban areas, very tight. These are things that cause major kind of accident risks, and it's something that we can deal with based on more off-site build that is assembly on site. This also means it's quicker. So quicker means less noise, less dust, better for the people and companies that work around that. And with that, because a lot of those buildings are factory built effectively, the build quality is much better. Now, I can speak from personal experience. I'm sure many of you listening on today will concur with this, that build quality in the UK, there's been plenty of TV shows, consumer kind of shows talking about snagging lists and faults with new builds. And if you're building in a factory, the tolerances and the repeatability of those materials and build systems mean that actually we should get that better consistency, and you have less problems when you kind of move in. That's obviously from a residential point of view, but some of these things still hold true in the commercial sector. But of course, the big one probably for the driver is, and on to the next slide, please, Dee, is the environmental and green building aspects. And underpinning all of that isn't just a let's throw some things and see if they stick scenario. There are technical standards that are developing and encouraging and incentivizing these kind of builds. So next slide again, please, Dee. I won't go all through these items. We haven't got the time, and you can probably read on the left-hand side the kind of definitions of these sorts of things. But the frank reality of the situation at the moment is that we live in in the West, we're living quite a wasteful society. We use water. You see the signs in hotels and the advice not to leave taps running when you are cleaning your teeth. Shower rather than bath, all those sort of different things. Wasteful packaging materials, wear once and throw away society in some sort of clothing lines that you've seen has been in the news over the last few years, and piles of clothes not being worn and not being necessarily recycled the right way. But it all underpins the fact that we are quite wasteful, and that's good practice not to have that. I'm sure everyone on the call will all wash up their yogurt pots as they're washing up at night and try and recycle, but even the recycle is still requires work. And if you look at the old days, and I'm old enough to remember these, where your milk bottles were collected, rewashed and put back on your doorstep, and now you're in plastic, and that has to be shredded and recycled. So you're still going through a fossil fuel and a carbon cycle to recycle something rather than reuse it. So all of this falls into net zero, and it's also into corporate and social responsibility, all those different factors. But what we should be encouraging is the use of things like the non-toxic, ethical and sustainable. And as we'll show in demonstrating the slides later on, those things around living in nature and the benefits that it gives you, and wanting to be surrounded by nature actually has lots of benefits from a pollution point of view as well. So on to the next slide, if that's okay. We have a standard in the UK. There are other global standards. Another one which is based around the United States, which is called LEED, LEED. In the UK, we have BREEAM or BREEAM. And that's been around for a long time. And as you can see on the slide, that goes back to 1990. It's run by the Building Research Establishment. And it was all there for benchmarking. So it was the idea that you could have new builds that would hit a certain level, which would be incentivized in planning and move things through from the old ways. Now, if you think of a brick and concrete manufacturer, it's incredibly carbon heavy. And if we can use things in a different way, then it's going to hit things that we're looking for in terms of net zero. Now, whether we feel we can achieve that globally is another matter, but it is a case of trying to have a more sustainable and ethical way that we operate. And on to the next slide, please. BREEAM has many different factors to it, and it's a weighted point scoring system. So you'd have various factors that you would bring in to play to make sure that we are building the building correctly. The ones that we've highlighted there are materials, pollution, waste, energy, and water. We've kind of already referenced, but bearing in mind what I've said around brick and concrete and how products are produced and delivered and manufactured on site, the energy efficiency part is probably the key one that we would refer to. Actually, from the sort of no entry sign fire symbol at the bottom is the one that there's biggest conflict within, because if you sit within an older property, again, be that commercial or residential, in those circumstances, you're going to use an awful lot of fossil fuels to heat it, and you also waste an awful lot of it at the same time. So you've seen probably the thermal imaging for when selling homes to make sure the energy efficiency is there and all those things that are rated. But the issue mainly with energy efficiency is that what's been used perhaps over the last 20 to 30 years and is a common feature are not sympathetic to fire, shall we say. There's materials that will burn sometimes fiercely, and it will allow it to spread to beyond the room of origin, which is a key factor when we're trying to look at sort of controlling fire. So there's a disconnect there. And that's something that we would look to play into, and something as a real takeaway from today. Next slide, please. Which, of course, is then insurability of buildings. Again, that's just a holding slide. So, Dee, sorry for the next one. Thank you very much. So, building regulations, and there's a lot of news, obviously, with regard to all the reports and the outcomes of Grenfell, which obviously happened many years ago now. But the building regulations will always underpin life safety. Absolutely they will. Of course they will. And of course they should. The trouble is that where life safety is concerned, that still relies on the building to be perfectly constructed, fully maintained, and everybody doing exactly what they need to do. But things don't really happen like that in life. And maybe sometimes the life safety aspect, even when the building was perfectly built, actually would creep into things where maybe it's not going to support life safety quite so much. So the building itself should be built to enable a fire to either be controlled to the room of origin, as I've mentioned, but effectively through the correct travel distance from any point of the building, through the evacuation routes, and to an ultimate place of safety, i.e. outside of the building. These are timed based on the height and depth and width of the building to make sure that everybody can escape. But if there's things in the way and things blocking it, and that's a classic example, things like a a locked fire door, for example, which obviously my team would be involved in checking, etc. This is where the waters are muddied somewhat. Green agenda obviously is environmental, as we say, but this is where all of that kind of consideration stops. We're the insurance industry. We're paid money to pay claims, but of course, from an insurer's point of view, when you look at terms and price, etc., it has to be looking at a tolerable risk. And where that margin is beyond that, that's where obviously difficulties of being able to purchase insurance cover will happen from. So the diversity that's mentioned there is a key factor, and of course that still plays into the health and safety aspects as well. We take, for example, just a perfect thing, which is the most tragic of all, of course, is Grenfell. But that building, 1950s, a concrete framed, floored and walled building, which for every insurer out there would consider it to be a fire resistant building. Its structure would last at least 2 hours, maybe up to 4 hours in a fire, and not collapse and not as restrict the evacuation of that building. You put something on for aesthetic and also energy efficiency benefits in the sense of a combustible cladding system. Well, we all know the results of that, and it was something that in hindsight you could see being potential. So the idea that there's engagement in this across all of the stakeholders, and that's through from planning, and something that we try to encourage is if there are customers looking at new buildings, let's get involved and discuss those things at that point. Let's not waste time, and let's not wait until something is built and go, actually, it would have been better if you'd built it this way. So that's really our aim, objective, and working with yourselves in MGAs and DAs is a key thing for us. Next slide, please, Dee. Just for information, I'm not going to go through this slide in any detail at all, and it will be in the pack as you receive at the end. But we've one part of Grenfell and the outcomes of the changes in regulations, etc., is a move to a European classification system. And whilst we're not part of the EU, we can still use these standards and contribute towards them. And the ABI, for example, would be involved in this as well. Is that we would look at the materials. It isn't what we'd refer to as a system test, which is effectively testing the outside skin, which if you think of a metal face, it can heat up, but a flame test against a piece of metal isn't necessarily going to ignite something on the inside in a perfect situation. So we'll look at classifications from A1, which is non-combustible, right down to F, being highly flammable or highly combustible. These things put a weighting onto a building in a percentage terms that would determine what an insurer would think is something that goes from the very best, being fire resistant, as I mentioned, down to a fully highly combustible building where we're going to have challenges in terms of normal terms and conditions. We'd also play into that things around smoke, because as we know, smoke kills, and it impedes various things in terms of firefighting, but also where you've got materials that are so combustible or so flammable that they're going to come off the building, drop to the floor, still flaming, still spreading the fire to other areas. So these are factors that we'll take into account. There's an organisation called the British Board of Agreement, the BBA, and they actually have individual records of materials that often we'll refer to and should be within documentation for buildings. And another challenge often has been that the materials we don't know, we have to go back or make some assumptions. So the more information that we get is better, and going for the future as well, the golden thread of information that as another outcome from Grenfell would find that available information on buildings will be far better. Next slide, please, Dee. So we're going to go through quite a number of different types of construction now. And one of the things that I think we got from a feedback point of view is something that you wouldn't necessarily refer to as modern methods of construction necessarily, because it's been around for quite a few years. But if you can move on to the next slide, please, Dee. But what we would refer to as modern method construction, and it's an ever-changing landscape. New things will come up undoubtedly in the next few years and make us question the whole process. And is this safe? Is it going to perform? And correctly in terms of from a regulatory life safety point of view? Will it have property benefits as well, just to stop and halt a fire in progress? So we're going to go through a number of these, not all of them. And again, it's a bit of a whistle-stop tour in the sense of time that we have. So if there's anything anybody needs that's a deeper dive, then we're more than capable of doing that at another time. So next slide, please, Steve. Composite panels. Say you can't really call it modern methods of construction. It was modern in the 1980s. Is it modern now? Well, it's still there, and it's still very much a regular feature of industrial and commercial buildings. But not to labour the point in terms of history, buildings from the 1970s, if they were industrial factories, warehouses, and so on, would probably be steel framed, unprotected. And walls would be a built-up system, so you'd have a corrugated metal outer face, and the early ones of those have no insulation in them, and very, very cold, obviously, to work in. Roofs and obviously asbestos would be part of this as well, which we know as another form of cost to people and to the industry. But we would be using things as insulation in the early days of mineral fibre, which if you live in a house and you go into your loft, you should have nice quilt systems of mineral fibre to give you some insulation there. Non-combustible, very good. Far better than the foam sprays that you might see being advertised on adverts, which effectively can be combustible. But fiberboard linings would be used, which is effectively layers and layers of board and paper and cardboard type approaches, all compacted together, which would be combustible and spread fire badly. But that was the norm in those kind of days, and the insurance industry understood that and the pricing. But into the 1980s came plasticized foam, as it was referred to, and the common term actually in those days was a sandwich panel. We still see that. We still that on broker submissions, which is absolutely fine. It's interchangeable with composite panels, so please don't think one is different to the other if you say it's a sandwich panel. But what you basically have is the sandwich being the outside bread, being the internal external metal facings, again typically steel or aluminium. But inside of that, and bonded with a glue, would be a foam insulation, which we're going to come on to. And suddenly these buildings were far warmer, to the point where actually you could go away from industrial commercial. You'd see them in retail parks, you would see them in leisure buildings, a much wider application. And the construction of these was a steel frame, and basically you'd bolt these onto the walls and the roof, and you've got very quickly an envelope of a building to work through. So you can see the advantages from that point of view. Next slide, please, Steve. However, and you'll spot a trend with this from things that have happened in the recent past, that suddenly we'll find that the performance of these buildings, which perhaps no one was open to the idea that this could be a major threat, or it might have been fine in test conditions, but in the real life scenario, suddenly we have some major incidents. So the two sort of standout ones from the early 90s was a fire at a Sainsbury's using composite panels. But the one that you might have heard from is the Sun Valley Chicken Processing Centre in Leominster in 1993. So I've talked before about ultimate place of safety and evacuation and life safety. The reality would be that low-level buildings, lots of fire doors, everybody would be getting out quite quickly. Sadly, in this case, there was a loss of 2 firefighters, and we just want to play this clip, which a program back in the 80s and 90s, which commonly seen, but started to bring to life and bring to the public domain actually the problems that some of these buildings might have.
Another large single-story building, this time a food processing plant in Hereford. Last September, a machinery fire started at one end of the works. Once again, those inside got out alive, but the day would still end in tragedy.
Just so fast, one minute you could be looking at a part of the building and it was clear, the next minute there was flames licking out the windows, smoke billowing out.
It didn't matter what measures we took to combat the fire. It just seemed to have no effect at all. It just kept spreading towards us, and eventually the whole of the roof and the whole of the building was engulfed, and eventually we lost the building.
The spread of it was amazing. We'd never seen anything like that. From a thin whisk of smoke in 1 minute to thick black smoke within about 10 minutes, completely engulfing the building.
Have you ever seen a fire like that before?
Never, no. God forbid, I never will again. It was by far and away the worst that I've ever attended, and that's in 22 years.
2 firemen were sent into the building to assess the damage. The fire was apparently far away. 8 minutes later, they were in trouble. The fire had roared through an empty roof space, trapping them. Because there was no barrier in the roof to stop the flames and no sprinkler system, the blaze was impossible to control. Not even the bravest rescue attempts could save them.
Thank you, Dave, for playing that. So those sorts of situations bring it very close to home, doesn't it? In the sense of loss of life for firefighters to loss in fire, is incredibly difficult to kind of take, and these things affect change. And again, we see it again today. Sort of 30, 40 years later, it's incredible to think of it in those kind of ways. But so from that point of view, in the 90s, when these things happened, insurers react to this because they're not entirely sure exactly where these, well, we know the buildings, but the exposure, the impact that these could have, the performance of the account effectively deteriorates to such a level that actually there's a panic situation that happens. So they became almost uninsurable overnight. And it was very challenging to find that, and restrictions in exposure and management of that. But the insurance industry does find a way for these sorts of things, and the key features of that to bring this back in line as to how do we continue to insure them is a few things. So the first one was that we need to understand what's actually in the building, because a composite panel building at the time, it's a steel-clad building effectively. What do we know actually is within there? But we want to manage those panels. We want to know that they are controlled, protected. And as I mentioned before, you've got an outside face, an inner face of that. But as soon as you breach that, and as soon as you expose the core, the insulation core, then we've got a problem with that, because that's where the fire is going to spread. So we want to make sure they're inspected, and there's a program in place for that. We want to make sure if there is exposed core, and that they are repaired safely, not with welding a panel over the top. And thirdly, that if there is a breach, because obviously you have to sometimes lay cables or pipework through panels, that they are appropriately protected so that a fire cannot penetrate into the core. And sometimes a big old hole's been pulled through, and you put a cable through, and you're exposing the core, and it's just a method for the fire to spread into it. So, but the third one, and the main one, which Steve, if you could move on to the next slide, is around third-party testing and accreditation of the materials. And this changed the market completely at that time. And as you can see from that image on the bottom left, the faces of the panels have metal on them, but the sides do not. So it allows a fire to continue to track through. And the fire in Leicester is exactly that it doesn't look necessarily that it's on fire, but effectively it's whipping through these panels. And you need an awful lot of heat from the outside to actually allow that panel to delaminate. I did mention that there's a bonded glue towards the foam and the metal face. If it delaminates, that's where fire is going to track through. So when we look at it from these categorizations, from the worst at the top, just to give it a focus, really, anything with polystyrene within it. If you think of, if you've bought a TV in the past few years, and the corners that are held in the box to keep things protected are polystyrene, it's a bead, normally on an expanded, so they're expanded foam beads. They would obviously compact together to create the core here. Extruded looks a little bit different. It's more like a typical foam, but are highly combustible, and would feature heavily in terms of insurers how that would be managed, or whether it's insurable effectively. Just be aware occasionally that buildings that may at one point been a food premises may not be anymore. So we can't always necessarily assume it's something better when it's not. Polyurethane was the big product. That was the main one that was being used in the 1980s, and again would be considered a combustible, in some cases a highly combustible foam. But this is where the market started to shift. So it was started to be recognised in the industry of how combustible it may be. And polyisocyanurate, it's taken me many years to say that correctly, but the PIR, which is easier to say, was chemically modified to make it perform better. But still a lot of variability in that. so still considered combustible, which is where the LPCB came in. And onto the next slide, if that's okay, Dee. Actually, it'll be the slide after that. Just go back if that's okay. Apologies. LPCB came in and actually created a standard which effectively would go. We've tested this in conditions appropriate, and the foam has been reducing its combustibility to such a level that actually insurers these days typically would look at it being almost like a standard material in these buildings, because there's lots of composite panel buildings out there in the industrial commercial sector. And they started to be built around 2001. So from 2001 onwards, the building is younger than that. There's an increasing chance that they're an LPCB approved product. We can sometimes find out if it is with an address. It's difficult to do that, but we can try that at times. And just finally on that, a mineral wall or a rock fibre, as has been mentioned before, insurers like that. The trouble with mineral rock, if there is any, is that it doesn't give the same degree of insulation and warmth to a building. It needs to be almost twice as thick to be as good as some of the foam materials, which obviously you lose internal space if you're to build in that way, but worth knowing, I think. Next slide, please, Steve. So again, here's an example of an exposed core. This is one of our business resilience managers on site recently, and suddenly you can see that foam, which will be a PUR, that kind of yellowy tinge to it, and that's a PUR foam. Effectively, any ignition on that, that's basically going to go through the building potentially, and that's a concern for accidental and deliberate fires. Again, you've got a lot of cabling, a lot of power cables. Any short circuits on a cable could ignite that as a spark. It's potential, something we'd look to be protected. But it also demonstrates to us that maybe they're not risk aware as a client, and they need some help on that, and obviously how they might manage that going forwards. Next slide, Dee. And the standards list, I mentioned the LPCB, which is Loss Prevention Certification Board. They have loss prevention standards. So if you see these terms being raised or given to you by clients, and things that we like to see if it's been tested, and they'll have certification for that. There's often not a lot of information, never enough information on site for what the construction build is, but that will be something that will be required going forwards. But LPSL 1181 is the cornerstone of this effectively, and 1208 is something for internal panels. There's also FM standards, and Factory Mutual being a US insurer group, we can also approve from them if they're bringing products into the UK. Next slide, please. So moving on to what we truly call kind of modern methods of construction. They are varied, they are common. We mentioned before about the actual modular type of buildings that go through. So we haven't got an awful lot of slides on modular, but there's quite a volume of it in the UK these days. But they are varied and they can change. So on to the next slide, Dee. They have been categorized, and it's worth thinking about these. We're not going to spend too long on it here, but just to give you a couple of examples here, it was a point to go actually what category is this as a material, as a product, as an end product. So the two that we'd probably see most common in this would be a volumetric or panelized. So category 1, volumetric, it is like a module. It's a full component structure of a building. It could be an entire room. And they would effectively bolt together. So that was what we refer to as volumetric, because the component being a module is a single piece, but it creates a room effectively. Whereas panelized 2D type could be an entire wall system. But again, these will be built somewhere else. They'll be built in a factory and they'll be moved into site. We're not going to play it because of time today, but again, when you get the slides, we would recommend you have a look at the Dale Christian School, which is it's a US build, actually. It's quite a few years old, but it's incredible to think a building of that size could be built so quickly, and it shows you through ground conditions what they lay in preparation for it, and suddenly a number of modules come to site, and within a very short amount of time, this building is built and ready, and you could have school kids in learning, which is incredible. But it's just something to be aware of, because once it's built, you're not necessarily going to know what it is. Next slide, please. Something else we see, and one of these options, it was on the categories earlier, was brick slips. Now I use the example of a drive-through. I'm not going to mention any restaurant chains here, but a drive-through restaurant or a coffee shop that it looks like brick. it is brick, but it's just a tile or a slice, as they refer to it as. And again, you've got the potential and the likelihood that you've got an insulation behind it. And again, can be polyurethane, could be polystyrene as well. And if you look at it, and a surveyor, from an insurance surveyor, be it broker or insurer, you can tap that brick and it feels like brick because it is a brick, but it's just very, very thin. So it's designed to look like other buildings, but what's behind it can be completely different. Next slide, Dee. Timber frame is a really big industry now in the UK, and there's various ways of building. We're not talking here your kind of 15th century coaching inn, where you've got solid oak that's been there for hundreds of years. These are lighter weight engineered products. So in a typical light timber engineered building, which can be of multi-story blocks of flats, if you've ever seen them during build, it kind of looks like a box of matches sitting there, because each section of timber is pretty thin. But it's the engineering which is building the strength within that entire structure. That are probably clad externally with a single skin of brickwork, internally being plasterboard in the insulation in the cavity. Can be all sorts of things, which again we're not going to understand unless we get the spec of the building. But if a fire tracks into the cavity, suddenly we've got a problem. There's been many examples of that in the UK, where fire has got into the cavity and it's whipped up the outside, over the top into the roof space, and even down below, even going, fire tracking. Gravity would think, and heat rising, you think it wouldn't be possible, but it also goes down the other side, and you are unable to support that building in the future, and it will come down and have to be rebuilt. But that has developed into other areas, which is more solid elements of timber, but still a timber frame and timber build, and timber is combustible. Regardless of what anyone would tell you, it will still be combustible. So glulam is something we see often. And if you went into a modern kind of leisure centre or swimming pool complex, whatever, and you see these heavy timber beams, often curved over the roof span, that's various layers of thinner pieces of wood effectively being bonded together, again creating the strength. And obviously it gives some real span capabilities of it. On to the next slide, if that's okay, Dee. Is what is, again, has been a lot in the news for the past probably 10 years, is cross-laminated timber. Now, if you look at the image on the right-hand side, you might be able to see that there are various layers to that. Each of those layers is called a lamella, a word of the day for you. But if you looked at, take an example of a stripped pine door, where you look at the grain going through that door, and then if you turned at a right angle, the next door, probably the best way I can describe it to you, build that up. When that's the cross laminate, the grain is going in different directions, you build it up until almost we can have up to 9 lamellas or 9 panels effectively, which, as you can imagine, where they're bonded, again with the polyurethane glue, but that actually creates incredible strength. And you can build, and whilst the image here has a steel frame attached to it, lots of these builds actually could stand alone as a load-bearing structure just with CLT. Now, the heavily use of timber is very dense on that basis. You couldn't easily set light to it with a match. It might char the outside, but what the performance of these, which is the bigger concern, is what may happen in a major fire scenario, not like a small test type environment. If you have the time at some other point today or later, if you wanted to Google the Italian Motorcycle Museum in the Alps fire, you'll see a glulam building, or sorry, not a glulam building, a CLT building, actually having a very significant fire. So we hear an awful lot around the fact that, don't worry, it's very dense, you're unlikely to set light to it. Just take that as an example, you might have a different conclusion, which would be probably the same as ours. Next slide, please, Dee. Another one, which again would be clad with various materials on the outside, you wouldn't understand it, is a SIP structure, and structurally insulated cladding. The word in the clue of the title there is structurally. So again, these are very strong. So you have a timber, it's an oriented strand board, an OSB board, which is effectively shredded timber, which is glued and bonded to create a panel. But it's held in place with a bonded piece of insulation within it. And this is a white insulation on the inside, you can see here, which clearly would tell us it's polystyrene and very heavily, highly combustible. Yet these buildings go up and again are externally cladded. So they can be used in a hybrid manner where it's on a steel frame, but effectively These will be overclad on the inside with plasterboard and outside probably with a brick slip or other materials. And again, probably only likely for 2 stories maybe, but we do see them. And again, these would be considered highly combustible and very concerning to the insurance industry. Next slide, please, D. Now, I'm not going to spend too much time on this, partly because of time, but also these have been heavily newsworthy with regard to Grenfell. But we've seen buildings that have these range screen cladding systems, and we hope we're in a position where we're starting to remove them. There's still a backlog of buildings that have any type of cladding system within them. One of the features of these is the fact that there's this ventilation gap, and it says here it's to allow drainage, but it's also giving a breather effectively to the panel, so it doesn't go mouldy. You don't get issues with internal damp, etc. But they're on the outside of the building, maybe a very solid building, and they've basically put this in place. There will be cavity, or should be cavity barriers in it to allow it not to spread. But again, it's a question of whether they're actually present in place. And there's lots of these external cladding materials in there. The government was concentrating very heavily on aluminium cladding materials, ACM at the time of Grenfell, which is because that's what Grenfell had on it. But effectively, there's lots of other materials outside of that that didn't get picked up at the time and have been now, but there can be a copper or zinc or terracotta system in place as well. And HBO is a high pressured laminate, which again could be a timber actual cladding system on the outside. Next slide, D. And this is what it would look like in practice effectively. So you've got your outside cladding facade, and then obviously you go inside with the insulation with the breather. But again, these would be fitted onto many buildings. Next slide, D. There's another type of system that you might come across where, again, a solid building, but you want to insulate it better. And this is different to a cladding system, but it's an external wall insulation, EWI. There's other terms, as you can see there. Again, can be polystyrene, it can be polyurethane. But from the outside, the untrained eye or the untrained knuckles actually wouldn't know it from anything else. It just looks like a concrete building, and it's used for new build, but also for upgrade. And on to the next slide, please, D. So as a trained professional in terms of risk surveyors or business resilience managers in AXA, you can do the tap test with these sorts of things. In that, you know, if you wrap your knuckles on it, the chance that it's going to hurt you if it's a solid concrete. But if it's hollow and lightweight, you're going to likely find that it's a polystyrene or a PUR behind it. In this case, this is a student block attached to a supermarket. And because the external render is so thin, it's quite easy to be damaged, and maintenance is an issue, and it's exposing the core. So again, it wouldn't take too much of an external flame to allow that to ignite and potentially spread over large portions of this building. Next slide, D. Again, these are the things that we're concerned about. It goes back to my original point about keeping a fire to its room of origin. This is allowing fire to spread and create secondary fire, so it spreads from room to room to room from the outside of the building. And obviously, we've seen that from Grenfell, but all of these buildings potentially have that capability. Next slide. So just moving the conversation on a little bit, or the discussion and the slides effectively, is we can find that because of the sustainability, because of the natural elements of and the well-being actually that comes from living within nature, we're seeing increasing numbers of green roofs, blue roofs, and green walls. So it may be on a traditional building, it may be on an MMC type building, but putting in grasses and seeding to actually increase for the biodiversity, actually the pollution that these will absorb at ground level actually makes it, you know, a very pleasant place to be. And again, this is evolution and development and all the things we would normally welcome. But obviously, there's a challenge from a risk management point of view for these. That there's an irrigation system putting water onto these to keep them alive. And in a blue roof scenario, you know, you put a lot of water onto the roof. So any maintenance issues is going to potentially come through and give you, water ingress. But these are doing things with harvesting the rainwater, so you can flush the loos, which again, a good idea. No reason why it couldn't happen. And we're seeing these retrofitting on some buildings. Again, planning has to be in there to agree it. So next slide, please. D. Green wall. Why would we bring this into slides rather than the fact that it's quite good for sustainability and environmental and well-being, is that if you've ever had the pleasure, or you've seen it on TV, of going to the tennis at Wimbledon, you see the ivy growing on these buildings. All looks very, very lovely, but the ivy's growing from the ground on the outside of the building. Green walls do not do it that way. They are a planted system, and they have plastic planters sitting on a framework behind it, often plastic as well, with an irrigation system, so plastic water pipes. You can probably see where I'm heading with this. There's an awful lot of things on here that are actually combustible, regardless of the condition of the actual the foliage or whatever. But the whole proportion of it effectively could be heavy levels of plastic on the outside of the building, which, when we talk about spreading fire and the ability to spread beyond the room of origin, this is some of the challenges that we would face. On to the next slide, if that's okay. The AXA actually sponsored an event to actually have the planter systems tested. We had to halt the fire test within a few minutes because it just got completely out of hand. And this is the problem that we face with these. Look good, good for sustainability. And again, this is where risk management has to come into place here, and where, from our point of view, and for Sam's point of view and Simon's with underwriting considerations, we need to know that these things exist on a building, or if they are being considered, so we can give good practical advice. Next slide, please. Because this is what can happen. If they fail to be maintained, if the irrigation is stopped for some reason, all of the grasses and the sedum actually dry out, and it becomes, in the summer particularly, can become tinder dry. So a lighted match is taking all of that out without any question. And that's not just the very dry leaves, it's the planters. And again, under the eaves of the building, you know, you're losing landos to that fire as well, effectively, and that's going to just spread fire further. So we can't compromise on the maintenance of these. We can't stress that point strongly enough, and making sure that it is reliable and is sustainable for the future. Thanks. Dee, next slide. So in conclusion, I think hopefully there's a few things in there, or lots of things in there, that would sort of raise some thoughts with you and information that you need to gain from clients to understand their buildings truly. Hopefully you understand, you know, the traditional build structures and know what to spot, and factoring in how old some of these buildings might be. So, you know, a building from the 70s, let's say, or even earlier than that, we probably know how it's been built, and you'd be pretty comfortable knowing that is definitely the case. But obviously anything newer, you know, we want to engage with that. We'll be taking pragmatic views on it. We want to help. It may be a risk management solution for it, or it might be so embedded in the building in terms of its insulation that may make it unattractive and within the rules of the scheme. But we're here to help. We've got a big team in the UK to support that, and you know, let's keep that coming. And thanks for your attention today, and I'll hand you back over to Sam.
Thank you very much, Rob. Yeah, a great deal in there to consider, and plenty that I'm sure will resonate with people, both in terms of their own experiences with composite panels, modern methods of construction. I personally live in a timber framed house. I didn't know this until we bought it, and it occurred to me that I was aware of the fact that there were considerations to be made from an underwriting perspective, but actually understanding a little bit more about it. And obviously now increasingly we will see modern methods of construction, composite panels. It is a very, very complex sector, and so actually getting more insight can only really ever be a good thing. So thank you very much indeed. We have got a little bit of time for some Q&A, and there have been a few questions which have come through on Slido. If anybody wants to ask any more questions based on what you've just heard, then please do. Slido, the details are up on the screen. Like I say, it's very simple to log in, and we may well have time to answer your questions. So I am going to take probably the first two questions which are on the list at the moment, both from Martin McBean. Hello, Martin. Asking about whether or not we're able to provide acceptable product specifications, SIPs and EIFS, etc. Simon, I'm going to bring you in here if I may be so bold. So Simon is a senior underwriter within our schemes department, and somebody who is very familiar with this particular area of the market. So yeah, Simon, would you like to elaborate on that, please?
Yeah, sure, Sam. Yeah, essentially in terms of guidance for the materials that we as underwriters sort of so look for are as per sort of, I think it was slides 13 and 19 really. It is obviously the Euroclass A1 and A2 combustibility core materials, which of course is the mineral wool, rock wool varieties. And I think going back to what Rob was talking about, being sort of pragmatic, we understand that in construction needs you are looking for the various properties that each of the core materials brings to a building. In an ideal world, we would have just materials used of A1, Euroclass A1 and A2, but we're obviously faced with the other materials. But obviously, once we start getting into that degree of enhanced combustibility, that is when, probably from an underwriting perspective, that's when we probably start getting a bit more curious about what's actually going on in the actual building.
Brilliant.
Sam, could I just add to that as well?
Certainly.
It's obviously for the buildings that's been mentioned there, and Simon's mentioned that perfectly, I think. But in the landscape of buildings, obviously we do insure combustible buildings. We've got lots of buildings out there with timber floors that would deem to be partly combustible, and insurers will use a rating. It varies from one to another slightly, so I've not put it on the slides, but from a fire resistant building all the way down to a highly combustible, and there'll be rates and terms for all of those, or to a point where it becomes unacceptable as a criteria. But there are materials in there, and it's how you manage it, and also almost the percentages of it at times. So again, if you've got a traditional roof on a building, you've got timber trusses and beams, etc. within it. It's how that rating would come in and how that factors into price, I suppose. But yes, obviously, we much prefer the A1s and A2s if we can get them.
Brilliant. Thank you very much, both. I'm going to jump very slightly here in terms of the questions in the list. So I'm going to address one of these myself, if my baby maybe so bold. So there's a question here stating, how much onus should there be on clients to know the method of construction for their building? Now, I suppose when I think about the onus of responsibility in terms of understanding this, it's less about kind of where that comes from and more about the appropriateness of the quotation that can be provided by virtue of a greater level of detail. I suspect that there are various people on this call who probably have struggled in the past at obtaining this information, because quite frankly, as I've just evidenced, when I moved in here, I didn't know it was timber framed. So quite frankly, it's quite likely that those people may not know theirs either, and that can be a problem, because it simply will not give us the necessary amount of information to be able to accurately assess the risk. Rob, I don't know, or Simon, have you got any particular views on whether or not that onus of responsibility should lie with a client, or indeed if there are other parties out there who could help?
I will add to that, if that's okay. I can jump in and beat you to it, Simon, if that's okay. But the one thing I'll say to everybody here, and is really important, is how can you create a competent fire risk assessment, which should be required for pretty much every building, if you don't know its construction? How do you know how the building is going to perform? So changes are coming. Fire risk assessors will all have to be accredited, whereas at the moment they're not. And the key factor of that is to understand the construction of the building, because if you don't know how it's going to spread, how are you going to keep people safe? So the onus is increasing. The thing I mentioned before in here is that there is the golden thread of information, which is again from the Grenfell inquiries have brought out that just not enough is known. We would love to have some data bank we could plug into that told us the construction of every single building. That's not going to happen probably for generations. But if there's an increasing knowledge of the building, obviously that underpins the insurability of the building and what the underwriters will do from an acceptability and pricing point of view. But there is a very big safety factor for that. And if you don't know, so in the operating instruction manuals, or the O&M manuals, operation maintenance manuals on a building, that's where a surveyor would be the go-to place to try and understand some of the materials. And I've been into rooms, quite large rooms. It's in one of the folders there, help yourself. And not very helpful. But there is an onus on, there is a responsibility for clients to do it. But hopefully through other means, through risk assessments, etc., that we'll start to understand the need for it. And let's be clear here, most buildings are absolutely fine. Everybody understands the construction of them. It's more into obviously the modern methods that we're talking about here, where we'd have some problems. But that also means that data should still be available quite readily.
Yeah, I was just going to add, and I think goes back to what Rob was saying in the presentation. There are clues, age of the building, how it looks like, what are the external features. So, there are, if you don't necessarily know the, ins and outs of the constructions, there are certainly clues readily available. And obviously, that's when sort of those conversations with us as underwriters and with the business resilience team within AXA, we can work together to do the detective work, and hopefully we can sort of come what may.
Excellent. Thank you very much, Simon. I'm slightly conscious of time. I tell you what, we've got a very hopefully a quite a closed-ended question that one of you might be able to answer for us. Are there any manufacturers designing rock wall panels?
Like that?
Are there any? Sorry, did you hear that, Rob?
I heard the question. Yes, I'll happily answer that from Paul. Paul, it might be worth having a separate conversation about that, but just for today, one thing I would say is, again, depends on which panel you're talking about, really. It depends if for load-bearing structures you can't use rock wool effectively because there's too much flex in it. It moves too much, so it can't make that solid SIPS panel. It can't make other types of systems where there's load bearing within it. You can get effectively a rock wool or other similar products named mineral fiber or rock fiber material that is available as a sort of a composite panel. But it goes back to the comments made earlier, is that the insulation properties will not be so big in them, so there's a wider span required for them. So again, it depends on what structures and materials you're thinking of, or the product types. Yeah, hopefully that answers it.
Thank you very much, Rob.
Yeah, hopefully I answered it.
I didn't give you a great deal of time, so my apologies.
Okay.
Okay, so we have got a couple of other questions there, which unfortunately we've run out of time. But please do reach out to your own independent AXA relationship managers, underwriters, business resilience managers. We're very, very happy to talk about this subject more, as you can tell. So we're coming to the end of the webinar. We hope that this has given you a broader and deeper understanding of some of the risks, but also the benefits of some of these modern methods of construction. It is very complex. As you can see from some of Rob's slides, there's a great deal of complexity in it. And so a better understanding as an industry can only ever really be a good thing. So please do come and talk to us about it. If there's a risk which looks complicated, we're a bit unclear on what those panels are, etc., then as Simon said, let's try and work collaboratively on it. We would much prefer to be able to provide a solution as opposed to not. So yeah, we're hoping to be able to work with you more and more. Let's be honest, some of these technologies and these materials, they're not going to go away, they're going to become more prevalent. So it's just important that we are working together on it as best as we possibly can. Finally, thank you very much for your attendance, for your participation. Thank you very much to our experts. We will send out a comms which will have a link to this recording and also include the slides as well, so you'll be able to review those back at your leisure. Beyond that, thank you very much again for your time, everybody, and I just leaves me to wish you a good afternoon. Take care.